Hello guys, welcome back to the channel. So today's LeetCode question 3742 maximum path score in a grid. It is a medium level question. Okay, let's go through the problem statement. So we have been given a grid and an integer k. Now this grid contains values 0, 1 and 2. The significance of this value is they come with a score and a cost. So when the value is 0, the score will be 0 and the cost of that cell will be 0. For 1, score will be 1 and cost will be 1. For 2, score will be 2 and cost will be 1. What we need to do is we are starting from the starting cell and we need to reach the end cell. And the allowed directions are right and left. So the goal is like start from 0 comma 0, reach m minus 1 n minus 1. What we need to do is we need to maximize the score and keeping the cost intact. So the significance of k is that whatever cost we are using, it should be less than equal to k. So for this example, if you see, the maximum score will be 2 because from the path will be like this 0 to 0. 0 will contribute to 0 to the cost, this 0 will contribute 0 to the cost, and this 2 will contribute 1 to the cost. So that and the score will be maximized by 2, because if we get this path 0 1 0, the score will be 1 only, so 2 is the maximum here. Okay, at first glance, it might look like a dynamic programming problem where the changing sets are I and j. And we will just store this in a DP and then use the normal logic and maximize the score. But consider this: if you have a path A like this, which gives a maximum score, and you have a path B like this, whose score is less than path A, but what if the cost that path A is giving you is greater than k? So we will have to skip this, right? And cost B which is giving us is less than k. So we will consider this. So and then what we need to do is we need to check all the paths, take the score and see which is the maximum, considering the constraint that the cost will be less than equal to k. So here will be the changing states of our DP array: I, the current row; j, the current column; k, the remaining cost allowed. So DP of ijk will represent maximum score from ij to this cell. So from 0 comma 0 till this cell with the k cost remaining. Okay, let's go through the recursion tree. So the allowed directions are right and down. Okay, so we are starting at 0 comma 0. So from 0 comma 0 we can go to 0 comma 1 and 1 comma 0. Okay, here and here. From this cell we can just go to 1 comma 1 and 1 comma 1. So when we reach 1 comma 1, we can just return the score, which is 0, right? And the score this guy will contribute is 2, because 2 is contributing 2 as the score. From this guy will contribute 1 as a score. Okay, so at the end we'll just take the maximum of 1 and 2 and return the value. Let's discuss the base cases also. So when I and j are out of boundary, just return the minimum value. Remember, we are calculating the maximum, that's why we are returning the minimum value. Okay, then if the cost of the current cell is greater than the k, so if suppose here the cost given was 0. Okay, now the cost contributed by 1 and 2 is 1, right? So when we reach this block, what will happen is the cost for this block is 1 and we have the cost as 0, so we can't proceed forward. We'll just return that this is an invalid cell. Okay, so just return minimum value. Third is dp of I comma j comma k is not equal to run, means the dp is already filled, return that value. And fourth, when you reach m minus 1 and n minus 1, just return that value. Like here we just return the score, right? Okay, for this case, remember, first just check that is this case also allowed. If the cost here was greater than k, then we will return just the minimum value. Let's go through the pseudocode. So we'll take the DP array m for total rows, n for total columns. Then in the second step, we'll just initialize this dp, m and n. So dp is equal to new int of m, n and k plus 1. So why this k plus 1? So allowed states, suppose k equal to 3. Okay, now the allowed states were this cost will be 0. We can choose the cell when the cost is 0. We can choose the cell when the cost is 1. Similarly for 2 and 3. In the next step, we'll just call the DFS, passing our grid, the changing state for row, the changing state for column, and the changing state for cost. Okay, so in the DFS function, first what we'll do, we'll check our base cases. So as discussed, the outer boundary case, the current cell cost is greater than k case. If the memoization is already filled, then just repeat, like return it. If you have reached the final cell, just return its value, the score at that cell. Okay, in the second step, we will explore all the possible paths, down and right. So we have called this down and right here. We'll take the maximum from this down and right. If the maximum is min value, then we will just add the min value to it. And if it is not min value, just add the score of the current cell, okay, to the calculated from down and right, and just add it to the memorization array and return it. So the time complexity will be order of n cross k, and the space will be order of n cross k. Okay, so takeaway from this problem will be, when you are encountering a DP like problem, okay, just see what all states are changing in that. Okay, so if there are 2 states changing, just create a 2D array. If the 3 states are changing like this problem, create a 3D DP array. So that's it for this problem. If you are in the same journey of interview preparation, you want the content on LeetCode, LLD, HLD or GenAI, please follow along. The code will be given in the description. Thanks.